On October 20th, 2025, a race condition in DynamoDB's DNS automation took out US East 1 for about 14.5 hours. Alack, Vemo, Coinbase, have the internet gone. That same day, 37 Signals deleted their AWS account permanently. Nobody planned that. It just happened to be the day the last workload came home. Now here is what makes 2026 different, and I want to be straight with you before we go any further. This is not the video where I tell you bare metal is cheap now, is it? Enterprise SSD contract prices jumped 80% in a single quarter. Hetzner has raised its prices 3 separate times this year, and Equinix shut down metal entirely. The cost argument for leaving AWS is weaker in 2026 than it was in 2023, and the case for leaving is stronger than it has ever been. Let me show you why, and exactly how to do it without taking your company down. Leaving AWS in 2026, the multi-cloud exit strategy. Chapter 1: The Death of the Managed Monoculture. Start with the bill, because that is what gets the meeting scheduled. 37 Signals published theirs, $3.2 million a year across AWS. After the exit, $1.3 million, about $700,000 in Dell hardware recouped inside 12 months, $2 million a year in savings, ongoing with the same ops team. DHH is very specific about that. The headcount never moved. GEIC housed the Encos version of the same Zoe, 200,000 cores, 30,000 instances, average utilization 12%, 103 instance types, compute load up 2.5% over 10 years, cost up 300%. Their published results after moving to open hardware: 50% lower cost per core, 60% lower per gigabyte of storage, and a target to bring at least half their cloud workloads back by 2029. But here's the part nobody puts in the thumbnail. The savings do not come from cloud being expensive. They come from 3 specific line items. What? The Managed Service Premium. An RDS Postures multi-Z pair on R7 G.4X large runs about $3,000 a month. The same silicon on raw EC2 with streaming replication you manage yourself, about $1,400. You are paying 114% premium, not for the machine, for the automation. Whether that is a good trade depends entirely on whether you already employ somebody who knows Postgres. Pavilion IOPS. A 1 terabyte IO2 volume at 20,000 IOPS costs $1,428 a month. $1,300 of that is the IOPS net the storage. You are renting a number. 3. The network. 9 cents a gigabit to the internet, 4.5 cents through an NAT gateway, and 1 cent per gigabyte each direction to move a packet between 2 availability zones in the same building. That last one is the tax nobody budgets for. In a chatty microservice architecture, it can quietly become your 3rd largest line item. Now the counter argument: because you deserve one. Stack Overflow ran their own data center for 15 years. In 2025, they went the other way to Google Cloud and unracked the last server in July. They said publicly that cloud costs them more and that the flexibility is worth it. Zynga spent $150 million building Z Cloud and crawled back to AWS in 2015. And the famous survey stat, 86% of CIOS planning repatriation counts companies, not workloads. IDC's own data says fewer than 10% are moving an entire workload. Uptime Institute found a third had moved production apps back, but only 6% left public cloud altogether, and 41% of the workloads that came back had been lifted and shifted into the cloud without ever being re-architected. Which tells you what this is actually about. It is not cloud versus not cloud. It is which workloads have a shape that a data center is simply better at. Chapter 2: Bridging the petabyte. Let's build the control plane, because if you cannot manage both sides from one place, you do not have a migration. You have 2 infrastructures. First, Asean, Terraform or OpenTofu. As of this recording, Terraform is on 1.15, still under the BUSL license. OpenTofu is 1.12 MPL2 under the Linux Foundation. Teams doing exes pick OpenTofu, and the reason usually is not features. It is that BUSL's non-compete clause creates real legal exposure the moment your platform team starts building internal tooling. GitLab's lawyers cited exactly that when they deprecated their Terraform templates. OpenTofu also has client-side state encryption, which Terraform does not. One warning: turning it on is a one-way door. That state file will never open in Terraform again. Second decision: the private side provider. For Proxmox, it is BPG/Proxmox, version 0.110 as of June. Not Telmate. That project has been in release candidate for over a year and never shipped a stable 3.0. For Nutanix, it is Nutanix/Nutanix 2.4, and the V2 API resources have been G since January of last year. In the minor version, BPG is still 0.x, which means no compatibility guarantee between miners. I have watched a team lose a Friday to that. Here is the shape of it. 2 providers, 1 root module, 1 state. And the gotcha that catches everyone. When you authenticate to Proxmox with an API token, SSH.username becomes mandatory. There is no password for the provider to inherit when it needs to upload a snippet. Now the actual bridge. You do not rewrite your modules. You alias the providers and you hand them down. The child module declares configuration aliases. It does not declare its own provider block. That is the single most common mistake in multi-provider Terraform. And to adopt the bare metal you have already wrecked, you do not run Terraform import 40 times. You write import blocks, plan with generate config out, and let it write the HCL for you. 3 blocks worth memorizing. Import adopts existing infrastructure declaratively. Moved refactors without destroy and recreate, and it lives in the repo where your team can review it. Removed with destroy equals false stops managing an EC2 instance without killing it, which is exactly what you want during the drawtime. One honest warning about the bridge state idea, the variable that shifts capacity from cloud to private. If you implement that with count, changing the number renumbers your indices, and Terraform will happily destroy and recreate resources you never touched. Use for each over a map of named instances. Always. Chapter 3. Data gravity and latency. Now the hard part. Compute is portable, data is not. Let's do the physics first, because it constrains everything else. 10 gigabits per second at line rate is 108 terabytes a day. 1 petabyte takes roughly 9.5 days. Call it 12 with real-world overhead. 100 gigabits does a petabyte in about a day. And you should know, the physical shortcut is closing. Snowmobile, the truck, was withdrawn in 2024. And as of November 2025, Snowball Edge is existing customers only. New customers get pointed at data sync. You are going over the wire whether you like it or not. The good news is price. Since March 2024, AWS waives internet egress for customers leaving entirely. As of the September 2025 update, it is a 90-day window, and there is no minimum volume. It is not automatic. You file with support first. 37 Signals had roughly $250,000 come to moving off S3, and DHH gave AWS public credit for honoring it. Do not skip the paperwork, and know that the UK competition regulator looked at these programs and found the windows too short. Customers reported switches taking 12 months or more. Now the link itself. Site-to-site VPN caps at 1.25 gigabits per standard tunnel. MTU 1446. No jumbo frames, no path MTU discovery. It is fine for control traffic. It is a bad idea for database replication. You can ECMP multiple tunnels across a transit gateway for more throughput, but only with BGP. Static routes will not ECMP, and that trips up almost everyone. Direct Connect is the real answer. A dedicated 10 gig port is about $1,640 a month, and egress across it drops from 9 cents to 2 cents a gigabyte. At 100 terabytes a month, that is $7,800 down to about $3,600. Port fee included. It pays for itself around 24 terabytes. And here is the counterintuitive part, the one that will save you a week. When you replicate Postgres out of RDS, 10 gigabits is almost never your bottleneck. Logical replication apply is single-threaded per subscription. You can saturate the subscriber while the link sits 99% idle. The fix is not a fatter pipe. It is splitting into multiple publications, so you get parallelism, and on PG16 and up, parallel apply workers for large transactions. 2 more things that will bite you. The replication slot is a loaded gun pointed at your source. WAL is only released when the consumer confirms it. If your subscription stalls RDS keeps WAL until the disk fills and the instance goes down. That is the single most common way people take production down during a migration. Watch PG_replication_slots like it is a heart monitor. And PG_create subscriber does not work here. It needs file system access to the data directory, and RDS does not give you one. It is a great tool for after you are already out. While all of this runs, the private site is not idle. It is a hot standby, serving reads through a local cache layer, with an edge gateway in front so you can shift traffic per route instead of all at once. Chapter 4. The Phase Migration Blueprint. 4 phases. In this order. The order is the whole product. Phase 1. Stateless services. Not because they are valuable, because they are disposable. You are not migrating an app. You are load testing your own networking fabric with something you can roll back in 30 seconds. What you are validating. Does BGP converge when a top-of-rack switch reboots? Does the load balancer VIP actually fail lower? Cilium's BGP control plane peers service IPS straight to the top-of-rack switch, which is why it displaced Metal LB for new builds. One less component. QBIP handles the control plane VIP. That is a different job. People conflate them constantly. And if the who patches the OS objection is what is killing your proposal internally, look at Talos. There is no shell to patch. The OS is an image you roll forward. Phase 2. Read traffic. Stand up a replica on the private side. Point your read-only queries at it, and watch your P99. This is where you find out whether your interconnect latency assumptions were fantasy. Say Metro Cross Connect is sub-millisecond, Cross Region is tens of milliseconds. If your app does 200 sequential queries per request, that difference is not academic. Phase 3. The database flip. Publication on RDS subscription on the private cluster schema pre-created because logical replication does not carry DDL. Let it catch up. Verify lag is 0. Then and only then, stop writes, advance every sequence, repoint, drop the subscription. Say that middle one out loud with me. Advance every sequence. Logical replication does not replicate sequence values. If you cut over without a set val on each one, your new priority starts handing out duplicate priority keys on the very first write. That is the most common self-inflicted wound in the entire migration, and it takes 4 lines of SQL to prevent. For the AWS stack underneath, Pevroney and ECT if you are on VMS, Cloud Native PG if you are already on Kubernetes, PG Bouncer or PG Cat in front. Phase 4. Drawdown. Do not turn a WS off. Turn it down. Shift 10%. Hold a week. Watch. Then 30. Then 70. The thing you are looking for is not average latency. It is the peak. Your private site has a fixed ceiling now. There is no auto-scaling group to hide behind at 9 a.m. on a Monday. 37 signals ran better than 4 nines across every app during their exit year. That is achievable. It is achievable specifically because they moved in this order and kept the old thing running. And the one to plan for. X saved $100 million a year exiting Sacramento, and took a 30-minute production outage doing it, after which Musk emailed everyone to pause the migration and freeze feature work. Both halves of that are true. Budget for the second half. Chapter 5. Sovereignty and the new bottom line. Let's close the loop on money, honestly. Storage is where the case is strongest, and it is not close. S3 standard is $23 per terabyte per month. Self-hosted object storage on spinning disk with triple replication and half an SRE loaded in lands between $5 and $10. 3 to 5 times cheaper, and that is before egress. Fastmail published their numbers. A petabyte a year costs $252,000 on S3. Their own hardware breaks even in under 12 months. But run the same model on all NVMe in 2026 and it lands between $27 and $74 a terabyte. That is at best break even with S3 and often worse. 12 months ago, that same build was $8. Enterprise SSD contract prices went up 80% in Q1, and NAND flash rose another 70% in Q2. Capacity relief is not expected until late 2027. So the honest 2026 answer, the flash-heavy cloud exit that penciled out in 2024 may not pencil out today. The disk-heavy one absolutely does. Run your own numbers. This quarter, not last year's, which is why the real argument has moved. On June 10, 2025, Microsoft's legal director for France was asked under oath before the French Senate whether he could guarantee French citizens' data would never be handed to U.S. authorities. His answer, no, I cannot guarantee that. That single sentence did more for European repatriation than any spreadsheet. In April, the European Commission awarded a €180 million sovereign cloud contract to 4 European providers. No U.S. hyperscaler won a lot. AWS launched its European sovereign cloud in January. €7.8 billion, a German holding company, a European advisory board, and critics still point out that the parent is American, so the Cloud Act exposure is structural, not contractual. And there is a deadline you should have in your calendar. Under the EU Data Act, switching charges and egress fees are permitted until January 12, 2027, capped at cost. After that date, they are prohibited outright. If you are an EU customer, your exit gets materially cheaper in about 5 months. Also, check your contract, because auto-renewal clauses can lock you into the old fee structure. Here is where I have landed. The managed service tax is real, and for a stable, predictable, storage-heavy workload it is between 2 and 5 times what the same thing costs on hardware you control. but the automation is real too. And if you leave, you are rebuilding CloudWatch as Prometheus and Grafana, EKS as Talos and Cluster API, and RDS as Patroni and a pager rotation that used to be somebody else's problem. Do it because you want the control, the predictable bill, and the jurisdiction. Do it in phases, with the old system still running. Do it with one control plane. Do not do it because someone on the internet told you cloud is over. Cloud is not over. The monoculture is. Every number in this video is sourced. Links are in the description. If you want the Terraform module skeleton and the Qtover runbook, say so in the comments and I will put it up. And if you have done one of these, I want to hear the part that went wrong. Those are the stories that actually help.